and I create amazing content on civil and structural engineering and construction at large. Today, I bring to you a very simple tutorial on how to design a retaining wall manually. And today, we'll just be focusing on designing retaining wall against sliding effect. Alright, so in the last tutorial, I was able to bring to us how to design a cantilever retaining wall using product structure, and I promised to bring about a way how to design the same retaining wall structure with manual approach. So you want to pay attention to a couple of designs we'll be making henceforth as we'll be bringing manual designs, manual solutions to all design problems. Right now, so today I'll show to us how to design a retaining wall against the sliding effect, and in further videos I'll be showing how to do that also against the overturning effect, and how to design for flexural um, reinforcement. Right, so in a very simple way, I'll be taking us through this as said, and I have a typical question at hand while we'll be using to run through our designs, and I want you to pay attention. In case you need any question, you have any question along the way, do well to use the comment section, and I will be there to respond to you. Thank you. So the question says, the cantilever retaining wall. This is a cantilever retaining wall, right? Shows you know a detail about this already. It's a cantilever retaining wall as seen. Shown below is backfilled with granular materials having a unit weight. So we have a value already, and you want to pay attention to all details that is given to you. There's a unit weight of 19 kilonewton per meter cube and an internal angle of friction phi of 30 degrees. Now, the last time when I was taking you through how to design with product structure, I showed you something about angle of internal frictions and cohesion around the field parameters. Assuming that the allowable bearing pressure of the soil, so we have the bearing pressure to be 120 kilonewton per meter square, right? And we have the coefficient of friction to be 0.4. Then we have the unit weight of reinforced concrete to be 24 kilonewton per meter cube. Determine the factor of safety against sliding. Right, so that's simple. Our adventure in today's tutorial is to determine the factor of safety against sliding. So the first thing you need to know is to achieve the factor of safety against sliding, the ratio of the restoring or resisting forces, restoring, or we call it resisting forces, restoring or resisting forces, the ratio to that of the sliding forces, the ratio of the resisting forces to that of the sliding forces should be greater than your factor of safety, which is 1.5. I already showed us some factor of safety in the last tutorials, how to design cantilever retaining wall using product structure. I told you about the factor of safety against sliding. I told you about factor of safety against overturning effect, and all of these are important in our analysis. Right, so to go further now, we'll just get to work, and in simple steps we'll be able to confirm that, then we'll be done for today. Right, so the first thing we want to do is to check or to confirm for our lateral earth pressure coefficient, which is called Ka. I call that Ka. Ka, that's the lateral earth pressure coefficient, and this is for active state. We have coefficients for passive states also, that's Kp, and we have Ko, right? So this is Ka, which we want to use for that for active state. So that's the active pressure now. So we have a formula to find that, and that is simply 1 minus sine phi, or sine theta, that have been given, over 1 plus the angle of internal friction that have been given. Alright, so this is simple. We have 1 minus sine 30 over 1 plus sine 30. So this would give us 1 over 3. Simple. Right, so going forward now, we have to find our active pressure. This is the coefficient for lateral earth pressure. I told you K is the lateral earth pressure coefficient. Then next is to find our active pressure. What's going to be the value for our active pressure? Pa. So this is obtained using Ka, which is the coefficient we just obtained, multiplied by the unit weight that have been given already in the question, then multiplied by the height. So simply you would have 1 over 3 multiplied by the density that have been given already, which is 19, this at top here, then multiplied by the height, that's 5.4. We have this height have been given here 5 meters, then we have 400 millimeters. So that is going to give us in total 5.4 meters. So that the active pressure we'll have now would be 34.2 kilonewton per meter square. Right, so we achieved our earth pressure, our active pressure already. So what to do now? And I told you that the factor of safety against sliding should be greater than 1.5. We have the restoring or resisting forces over the sliding forces should be greater than 1.5. So what we do now is to obtain what is the value of the restoring or resisting forces and what's the value for the sliding forces. Then we compare the two of them, and we'll be able to obtain whether it's going to fail due to sliding or is safe against sliding effect. Right, so what we want to do now is to find the two of them that we compare and will be good for the day. Right, so to find the restoring or resisting forces, so we'll call it the resisting or the restoring forces, and these are forces that seem to hold your retaining wall in position. They tend to put it in a stable position, while the sliding forces are forces that are trying to move it away from the stationed position. Right, so if we clearly look into the whole thing properly, we would see that we have certain forces that wants to keep this retaining wall in position, and we have other forces trying to keep this retaining wall out of order. Right, the first of those forces is the weight of the retaining wall itself. It tends to keep it down in position. The weight of the backfill also tends to keep it in position, and the weight of the base tends to keep it in position. Now this automatically gives me a definition for a cantilever retaining wall, which says that the weight of the structure itself and the weight of the backfill material would influence the stability of the cantilever retaining wall. Right, so we have that in mind already. So the summation of all these forces that is available in question would give me the number of resisting forces. All right, will give me the value for the resisting forces. So can we just do that? Then we check for the other one for sliding effect, and we'll be perfect for the day. Right. So the first of all we want to look at for the resisting or restoring forces will be the weight of the wall. The weight of the wall. Weight of wall. So I told you of the vertical stem. So this wall now we are considering it the vertical stem. The vertical stem. So let me put vertical stem. If you I explained vertical stem in the last video, which is going to be this vertical part of your retaining wall element. Vertical part, yeah. So for the weight of the wall itself, that would be 0.4, which is the thickness of the wall, which is rightly shown here, 400 as the thickness of the wall, multiplied by the height of that wall, which is 5. It's not 5.4 now, since we are dealing with the vertical stem only. Then we multiply by the unit weight of concrete that has been given already in the question as 24. So altogether would have a value of 48 kilonewton for the weight of the vertical stem. Then we have also the weight of the base of the wall, the weight of the base of the wall, right? So that would give 0.4, which is the thickness of the base, multiplied by the width of that wall, which is going to be an addition of 700 plus 400 plus 2.9 meters, right? So that will give us 4 meters in total, multiplied by 24, which is the unit weight of reinforced concrete, and altogether we have 38.4 kilonewton. Then we have another one which says the weight of the soil. The weight of soil itself now, which is the backfill material, is going to be the width of that backfill of the heel. Now I told us what heel means in the last video. Please, you can check to identify the parts of your retaining wall so that you can fit into the movement as I speak about them. So the weight of soil will be the width of that backfill side of the retaining wall. That's going to be 2.9 multiplied by the height of the fill of that soil, 5, multiplied by the unit weight of the soil, the unit weight of the granular material as given in the question to be 19 kilonewton per meter cube. So doing that, we'll have 275.5 kilonewton, right? So you will discover a thing if you're attentive. You discover that the unit of something like our unit weight of concrete is kilonewton per meter square. So multiplying kilonewton per meter cube rather, kilonewton per meter cube rather, multiplying kilonewton per meter cube by 5 meter and by 0.4 meter should leave our unit as kilonewton per meter, right? But because we are designing, we are considering a 1 meter, considering 1 meter length of wall. So we're multiplying by 1 meter, then we have our load in kilonewton, right? So these are the forces that tend to resist the sliding effect or sliding force. So the summation of these forces should give us the summation of the vertical forces now should give us 361.9 kilonewton. right? This cool. For the other kind of force that tends to pull the structure away from its stable position, and that's going to be the force due to the active pressure, the lateral earth pressure, right? So that's going to be the sliding force. So let's check for the sliding force, then we will conclude from there. So for the sliding force, and we are well aware that this is as a function of this area, the area of that particular structure here, and that's why I have a triangle here, the area of that. So that's going to be due to that. So the force is acting at the centroid of that triangular section, and the force exactly is going to be the area. The force itself is going to be the area of that triangular shape in itself. So we'll have the horizontal. That's the horizontal. That's the only horizontal force acting in that direction, and that's the only force acting against the stability of our structure. So the sum of horizontal force now would be the area of the triangle half. Now the base of this triangle is what we have already obtained before as our Ka rho h, which is the pressure, the active pressure. Now I told you that's the active pressure. So let's just indicate it for clarity purpose that this part of your wall is the active pressure, right? Of the shape rather. The value there is equivalent to that of the active pressure. So we have half the base is 34.2 as we have obtained before, multiplied by the height of that figure, which is 5.4. Right, so this calculating this should give 92.34 kilonewton. Right, now there is something you need to note right here before you continue. Your frictional force needs to come in. Your coefficient of friction actually is to be applied to the resisting forces or to the vertical forces, right? So we multiply these by our coefficient of friction. All right, so it means that it leaves us with a formula, or our formula now would be this mu coefficient of friction now multiplied by the resisting force or the sum of the vertical forces all over the sum of our horizontal forces, right? So this should give 0.4 multiplied by the summation of the vertical forces would be this value obtained here. We have 361.9 divided by the horizontal force 92.34. Now these together will have a value which must be greater than 1.5. Once it's less than 1.5, your retaining wall is not safe against sliding effect. So we need to prefer several other solutions, of which I'm going to show to us in upcoming videos. Right, so the result for this would be 1.56, which is greater than 1.5. That means your structure is safe. Safe. Let me pull that correctly. Structure is safe against sliding effect or sliding forces. So this is simply how we design retaining wall against sliding effect, or you check for effect of sliding forces against your retaining wall. Right, if you have questions around this video, you can please do well to use the comment section. I'll be there to reply you and to respond to all of your questions. Right, and do well to share this video with your colleagues that should get better with structural engineering. If you are joining us for the first time, use the subscribe button so that you can catch us live as we go on to some other videos on design and construction. Thank you for watching. See you in the next video. Bye.